Berg Knowles Theory Podcast.
Welcome to the Berg Knowles Theory Podcast, where we discuss AI and how you can actually use it. Our goal is to ensure that you, our listener, have the tools, knowledge, and understanding to leverage AI to simplify and automate areas of your life or business. I am your co-host, Ian Knowles, and I'm here with my main man, Harry Berg. And on today's episode, we're going to do a deep dive into machine learning. So yesterday, we gave you guys the kind of general framework for what AI is, what machine learning is, and what deep learning is. And today, we're going to dive into machine learning itself. So all the fundamentals of machine learning, what it is, how to use it. And before we get started, I was doing a little bit of work on, really trying to understand machine learning myself. So I'll start us off with a quote from Arthur Samuel, who was a pioneering computer scientist who studied artificial intelligence way back in the 50s. And he described machine learning as the study that gives computers the ability to learn without being explicitly programmed. So fast forward, to today, we're, 65 years in the future. And I think that principle remains true. So I'll turn it over to you, Harry. And what are your thoughts on that? And let's dive into it.
I mean, it picks up from what we talked about in the last episode, where I said AI is an approach to automation. And some things are very hard to automate because they're hard to write down the explicit rules for how to do them. It's hard to describe how you drive a car. It's hard to describe how a robot walks, and hard to describe how to respond to emails. For those kind of problems, it's useful to have systems which are machine learning systems which learn the rules for themselves. So they learn from that data without being given that step-by-step process they need to follow. That's what creates these machine learning systems. And these machine learning systems, these are the things which power all of the state-of-the-art AI systems which we use and love today, like ChatGPT, like the AI across all of your favorite apps, Netflix's recommendation algorithm to Instagram's recommendation algorithm to the self-driving car capabilities that are coming out to, automatic filters, Google Photos, all these kind of things. They're hard to describe how to do, but we can have machine learning systems learn how to do those things without being explicitly told. So absolutely right.
And within machine learning, there's three primary types, if you will. You've got supervised learning, you've got unsupervised learning, and you've got reinforcement learning. What do those things mean?
Yeah, this is such a good throwback. It's been years since I've taught this stuff, but you got those three major categories of how to go about machine learning. So I said AI is an approach to automation, machine learning is an approach to AI, and these three things, supervised learning, unsupervised learning, and reinforcement learning, are approaches to machine learning. So again, it's this kind of stack of technologies which we're zooming in on, getting into the specifics now. As we said, machine learning is learning from data. And the big thing which distinguishes supervised learning and unsupervised learning is whether your data has a label or not. Let's say I want to build an AI system which predicts what filters to apply on your photos to make them look your best possible. Do I have a label of which filters are the right filters or not? Maybe I've got examples of all the filters that people have applied previously on Instagram and then gone on to post and got lots of likes. So that would be a signal of basically, here's the right filters to apply. Or do I just have the image and I don't have a label of what needs to happen? Another example might be, let's think about AI for segmenting different customers to predict which group of people they fit to determine which email campaign we're going to send them. Do I have a label of all my historical customers of which category they fit into, or do I just have the list of customers? The case where you have the label of which category they should be labeled as would be the supervised learning case, and the case where you don't would be the unsupervised learning case. And so that's the difference between supervised and unsupervised learning, is whether you have that label in your data set, or more specifically, whether you use the label, whether you have it or not. And then you have this reinforcement learning setup, which is slightly different to supervised learning and unsupervised learning. So reinforcement learning is inspired by how we as humans and animals live. That is, we experience our surroundings, we take actions, and the environment either rewards or punishes us by, making us feel pain or pleasure or other emotions. And then we adjust our behavior accordingly, and then continue in that environment, action, reward process, and continue to go on and on. So the key thing about reinforcement learning is that you have this agent, some entity, like a person or a robot or a video game character, which interacts with this environment and then receives feedback from the environment. So it learns through that process of experience.
So you can think, supervised learning has human intervention, unsupervised learning, no human intervention or very little.
So it may be human intervention in the sense that a human has provided the label, or it may be that the nature of the data is that it's already labeled. So for example, if you want to build a system like ChatGPT, which predicts the next word, it's effectively what it does, word by word, it predicts what word comes next, then you may already have the label in the data because you've got a big block of text. And so that text is effectively already labeled because you've got the next word. It wasn't that a human had to go along and say, this is the right word that should be predicted. It's just that there's lots of text which is already out there. And so in this sense, it's maybe another piece of jargon to throw in here is it's self-supervised learning. So somewhere between supervised learning and unsupervised is the data is self-supervised. That is, by nature of the data, it comes with the label. So trying to think of more examples off the top of my head now, but yeah, the text modeling one is a really good one. Where if you want to build these systems, language models like ChatGPT or like GPT AI, which powers ChatGPT, then the data there is self-supervised because that text is in effect its own label of what words need to come next. So you would start with this big paragraph of text, and you would cut off the end of that, which becomes the label, and you leave the beginning, which is the input. So that's self-supervised learning. Simplistically explained.
And when you say when you say label, does that mean you're assigning a certain value to each individual set of data?
So let's say that. So in machine learning and AI, you've probably heard the term model, right? The model is the thing which takes in some input, maybe your prompt to ChatGPT, and the model generates the output, which in that case would be the response to that prompt. So these models, they are these input-output transformations. They take in some input, they transform it to produce an output. And really, any problem can be phrased in that way. I've got some input, I want to make a prediction about the output. And so the question is, what does that transformation take in and what does it produce? The label is what the model will learn to output. So in the supervised learning case, where you want to be able to make predictions, which basically take in some input and it predicts that label, the only reason that the model knows what kind of predictions it should make is because of what labels you show it. So if you change the label on a series of data points, then the model is going to learn to predict a different label. So the model is this thing which takes in an input and makes a prediction. Let's say you want to predict someone's height from their weight. So you have this number, which is their weight, and it's in kilograms. You want to predict their height. How do you represent their height? Is it in feet and inches? Is it in centimeters? Is it in meters? Depending on what number you use in your data set, that's your label. And so whether the model outputs, roughly, 1.8 or whether it outputs 5.10 depends on how you define that label in your data set. So if you change the way you're expressing what the model should predict before you train it, then during the training process, it's going to learn either, predict around 5 or 6 or predict around between 1 and 2.
And how much data is being pulled from what's available on the internet to arrive at that output? So does it have, does it go query the entire internet and say, and ask the question, or the system doing this, analyzing, people that are 5'6" and weigh 200 pounds, like what is the circumference of their waist on average, or
Yeah,
or some
great question.
combination of pulling that information together. How does it know? What's the basis of knowledge that it's utilizing to ultimately come up with the equation that delivers the output?
Yeah, great question. So depends on the model and depends on what data the machine learning engineers have retrieved in advance of the training process. So these AI systems, they're not learning in real time, and they're not going out and interacting with the internet or any other resource to learn these things in real time. They have already learned the stuff which they need to know. If they do go and do internet research, that's a different thing we can talk about later, where how they extend the knowledge they already have. But these AI systems are already intelligent by the time we're trying to use them. So when you talk about, okay, how is an AI system making predictions? It's not that it's going and doing this research, but it already knows this pattern. It already knows, okay, when I find somebody who's 1.8, when I find somebody who's 60 kilos, they're going to roughly be this height. It has that understanding already built in, already stored in the parameters of the model, the numbers which are used to take in that input weight and perform a calculation to make this prediction. So, and then your question was like, how much data is it using? This really depends on, how much data has been collected. So before we create this machine learning model, typically the case is we're doing supervised learning. So we want to have a data set of examples and their corresponding labels. How much data has been collected clearly depends on the team developing the project. So it might be that your Instagram and you've got, 1 billion or 2 billion users worth of data already stored, from the past 15 years. Or it might be that you are a medical researcher researching on a newly discovered disease, so you've only got 30 samples. So how much data these systems have been trained on, or how much data does an AI system use, is really a very case-specific question. But it depends on the team, depends on the availability of the data, and getting more data, might depend on the cost or the type of problem you're tackling. If you want to use medical data, it's going to be expensive to obtain, and it's going to take a long time to obtain just by the nature of it. Whereas if it's social media data, you might have the opposite situation. It's cheap to obtain if you own the platform, and you can get it very quickly because there's so many users out there. So how much data does an AI system really depends on the team developing the project. And then how is that data used? It's not used like a lookup when I'm scrolling through Instagram or I refresh my Instagram feed. It's not like the AI system goes out there into the database of all the previous posts and kind of aggregates that information. Instead, it's that all of that information has already been used to inform the right settings of this AI, so that when you give it when you refresh the feed, it does some calculation with the numbers which have already been calculated during the training process to predict the right feeds to show you.
I want to spend a moment on this because I think there's a lot of people that don't understand how social media, really works, and I think it's an interesting topic because there's a lot that stems from it. So with Instagram, we'll take Instagram to start. They've got an algorithm. There's AI all over the place with embedded within Instagram, within Meta, and it's a very, very complex tool behind the scenes that ultimately delivers a fairly simple user interface. So, and I assume that under the hood of the Instagram app, there's a very, very powerful machine learning capability. Right, that's probably fair to say. So, when thinking about how it actually works, and let's say my engagement is mostly just looking at and liking things. As I'm scrolling through Instagram, by the way, I don't spend a whole lot of time on Instagram, but if you're scrolling through it, And the reason why I say this is I don't know if I'm a great example in terms of like user data, although I understand that they're collecting every single second you spend on there and they're utilizing it for whatever it is they're utilizing it for.
That's exactly right. Yeah.
I try to use it as effectively as I can, and I keep folders, and I keep folders of things that are important to me that are useful in various functions of my life, and I don't doom scroll. I think we all
nice and organized. So you're really giving them high quality data, Ian.
Yeah, I'm giving them high quality data. Yeah, I keep it to certain functions of my life that are important to me, that bring value to me, and that's about it. And I limit it to 10 minutes a day, if that. Took me a while to get to that point because I was very interested in all the things going on in the world and found like everybody it interesting to double click and dive into all of these topics. Nonetheless, so I like that it
sucks you in. Why? Because it knows what you want. Yeah. It knows what you want because of the way you've interacted with it. So absolutely, to your point, every single interaction, from how long you look at a post to who you zoom in on in the pictures to every single thing, every single way that you can interact with Instagram, that is absolutely tracked. And not just Instagram, but TikTok probably to a bigger extent, and basically every other large-scale social media app out there. Every single little tiny interaction will be tracked, and that's so they can store all of these interactions in their data set, and use that to build a model of each of us, and a model in the sense that they've basically got they've got a way to predict what you're going to do next. And so they can use that to inform, okay, well, if I want him to stay on the app, what are the series of things, what are the series of posts or series of pieces of content which I can show this user to get him to engage more? That's how these algorithms work, to my understanding. Never worked on these kind of projects or at any of these kind of companies, but I think it's pretty fairly well known that that's the objective. They work off ads and engagement, so they want to maximize your engagement. They look at everything you do to try and predict how to get you to engage more, and then they run that to you. Hopefully that aligns with what we want these platforms to do with us, because otherwise we're in a very bad place, which may well be the case.
And that idea of this war that many people are at with social media, this sort of mental war where they're being pulled in and they don't want to be pulled in, but then it becomes habit, and then they're there and they find themselves for an hour before bedtime, or every time they have a moment, they can't just sit with themselves. They always have to be engaged in some way. And it's mostly consumption. It's not production. It's just consuming information. Some of it good, most of it bad. And, we could go down a whole rabbit hole on social media and the pros and cons of it. But anyhow, I want to understand.
I mean, it's not the system's fault. I don't think. Personally, I don't think badly of social media, because it makes sense that that's how they optimize the platform, right? That's a very simple objective of theirs. They want people to engage more, and so they show you more of what you engage with. The problem is really, what do you engage with? What does your dirty little mind want to see more of? And that's the kind of thing that you interact with, which is why you get shown it more. So, who's to blame, really? Is it the platform which is following a very simple and obvious rule that makes a lot of sense, or is it the way that each of us think and our temptations and lack of discipline?
Yeah, exactly. And you could make the argument that the creators of these technologies should keep those things in mind. But when it comes to building businesses, and certainly in the face of capitalism, big investors, big advertisers, engagement is critical. And so I think they, more times than not, kind of brush that moral function under the rug. And I mean, should they not? I don't know. This is, that's a whole different conversation, because their business is built on engagement, right? So they're delivering what they're supposed to be delivering. And but I do think that that's what scares a lot of people about AI, is the fact that these tools can be created to, in a way, hack your mind. And when you have your technology with you most of the time, I think, most people are actually trying to find ways to disengage, but feel it to be very difficult for they might find themselves not knowing what's going on, which maybe that's a good thing, that's a bad thing, not being up to speed on the latest trends and topics, missing out on opportunities. Like, I see the cell phone and the computer as sort of the modern day river in a way, in that, society used to gather around waterways because that's where commerce was. And now computers and phones is ultimately, for most people, where commerce is. And if not directly, certainly indirectly. So it's a tough thing to always have, always have these things around.
Yeah. And I'll just reiterate the point you made there, because I think it was a really great point. These AI systems that exist today are absolutely hacking your mind, because they have a very simple process to do it. The process is, look at how this user engages and do more of what we can do to get them to engage. And so, they're taking advantage of all the information which we show them to get you to behave in the way which they want. So it makes perfect sense. They're simply collecting that data and then having a AI system predict what you will do next, and then show you the content which will make you engage in a way that they want you to engage. So push all those metrics. Right. You behave in a way that's very irrational. But when these algorithms have that simple objective of increased engagement, it's very easy for them to optimize, especially when they're doing it at billion-person scale.
Right.
Because you've got such strong statistical significance of what people will do, how they will behave. You've got so many other example individuals using the platform to reference, okay, I can tell Ian is like this person over here. I've seen that person like this content, so Ian's going to engage with that too. There's a lot of information. Probably our most personal information is on these platforms. And so, they have the easy ability to hack our minds with the setup which they've got there. Again, show content to maximize engagement and track all of that, so you can understand the patterns of how to do that more in the future.
And on the other side of the same coin, AI is possibly the solution to less engagement as well. Possibly. In
many different ways, possibly. Absolutely.
Yeah, in many different ways. I mean, a lot of people that I talk to, almost everybody that I talk to, wants to spend less time on their phone, less time on their computer. Especially if you're a knowledge worker, it's just how a lot of things get done, right? But at the same time, when just looking at the expanse of one's human experience and life, I think most people would not, I don't speak for everyone here, but I think a lot of people don't want to look back on their life and say, holy shit, I spent, 30% of my waking hours, 50%, 60% of my waking hours tied to
those screen times are crazy, aren't they?
Crazy, right? I mean, if you think about it, if you spend 1 minute a day on Instagram, it's 365 minutes, right? And then most people are spending way more than that. I mean, people are spending weeks of, in some cases, maybe months of their life, on social media. And what are they getting out of it? Is it purely for entertainment purposes, easily. Or are they using it constructively and productively? So anyway, I want to go back to Instagram really quickly. So when in the framework of Instagram, and ultimately how we can kind of frame machine learning for ourselves in terms of how we guide a model to deliver an output that we want, or outputs, plural, that we want. So the engineers of Instagram, they say, they feed into the model, we want to track this, list of actions, right? And it can be, and I'm sure that list is very, 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 very long. Everything from how much time does someone spend on a post, to who do they zoom in on, to who do they like, to what they search, to what they spend most time searching, what content are they engaging with the most, who are they sending stuff to, what are they sending to those people, the list goes on, right? And they're tracking all of that.
Exactly. So absolutely, there are so many things that are tracked by not just social media products, but by pretty much all the products that you use. And eventually what happens is all of these things become what we call features of the data point inputs. So the data points have inputs and outputs. We want to be able to predict something such as, what do I show this person next on YouTube from these inputs, from the inputs, and the inputs are made up of features. So, it might be some, let's say you've got very simple features such as your age and, whether you went to a top college in the US or something like that. And also, how many how many accounts you follow on this, and how long ago it was since you last engaged. Those might be some example features that you might see on some social media platforms. Those are numbers which represent this input matrix. You stack all those numbers together, forms this grid of numbers, which are called a matrix, and those are the mathematical inputs which are then processed by this machine learning model to make a output prediction. So that's how that fits together. That prediction might be, it might be 0 and 1 of yes or no, should I or should I not show this person this post. It might be, categorical from 0 to 10 of which category of user do they fit in. Maybe coming back to the user customer segmentation example which I gave earlier. Or the prediction might be a continuous number, such as like how much longer do we expect the user to spend on the platform.
And what, from your point of view, what is a constructive utility of machine learning? I generally I think a lot of algorithms and particularly social media I've got a strong opinions about, but I think a lot of people do have concerns about AI for this reason. But the good side of it is that there is legitimate constructive utility to algorithms as well, right? And I think that's what everyone's looking for.
Yeah. I mean, I think a great utility of AI is the recommendation systems that we get on social media. Yeah, the content I get is great. It's very useful. It's exactly what I want to see, frankly. There's a lot of doom and gloom about it, but I imagine it would be a lot worse if I wasn't showing anything that appealed to me, or that was interesting or relevant or useful for me to talk about or share with my friends and connect with those. So I think recommendation systems as a whole, which exist on all kinds of platforms from YouTube, Netflix, Instagram, eBay, Amazon, all these kind of products, I think they're immensely useful because they help you get more of what you really want to see. Related massively beneficial use case is content filtering for things which are inappropriate, harmful, terrorism, hate speech, this kind of stuff. Like, I think that's a great use case of AI. And maybe you've seen some platforms out there in the dark corners of the internet where they haven't got that system set up, and it's just, wow, you didn't think you'd see this kind of terrible stuff that's out there. But maybe the internet would be more flooded with horrifically harmful viral content if there weren't these systems that could understand that and at least deprioritize it in the feed, because it knows that I don't want to see some of that stuff or any of that stuff.
Right. Yeah,
so there's some good use cases there. In the future we could deep dive into those, or we could keep bringing them back up because they're really good examples. Content filtering and recommendation systems. Coming back to our definition of machine learning, those things very hard to describe, but very easy to identify. Right. It's easy to identify when something is harmful content or inappropriate content, and it's easy to identify when I like this feed of content I'm getting, or I don't like this feed of content I'm getting. Because it's easy to identify, it's easy to create these data sets, or at least it's very possible. Whereas it would be hard to write down the explicit rules for how to define what is harmful, what is not. Those things are really nuanced. Right. So yeah, the machine learning we talked about was learning to do things without having the explicit instructions. It's hard to write down the instructions for what post should show next, but but you can learn those things from examples. from those data sets, which are easy to label.
Right. Well, that is a lot for today. There's so much more that we could go into there on machine learning, supervised, unsupervised, reinforcement, and certainly Instagram, one of the most powerful algorithms on the planet. But let's leave that to the next episode. Thank you, everybody, for tuning in to the Berg-Knowles Theory, and we will see you next time.
Absolutely. See you next time.
The Berg-Knowles Theory Podcast.